We'll talk about constraints. Constraints also known as integrity constraints. So what is the meaning of integrity constraint? I will tell you. When you have a table, so that means you are storing the data, correct? Example, consider student table and you store the data like this. One student named Raju and his age is 20 in that way. Okay. Student 2 Rani, let's say age 18. Now, sometimes what happens, so some kind of data is not allowed in the table. That means, this table is not meant for that kind of values. Example, let's say you have a restriction that every student should mention the age, his age or her age. Example, let's say there is a person 3, newly entered data, name Vani, and Vani want to have age value null, okay, but you don't want it, so you want to say that it is illegal data. So this is called important thing here, legal data, illegal data. So what is illegal data for your for your table writing null value here, let's say, that is what one constraint you have. Okay, so then we say that somehow if you stop the people, otherwise somehow if you stop people, otherwise if you don't allow the people to write null value here, then we say that you are ensuring one condition, that is you are protecting your data, right? So you are only allowing the legal data, so that is called integrity constraint. For that, whatever the conditions you mention, they are called integrity constraints. Example of one integrity constraint to not fill here null values is, we should impose a condition called age is not null. Yes, so on field of age, while creating the table, we can mention that age is not null. If you do that, DBMS will protect that thing. From now onwards, whenever you enter this kind of data 3 comma 1 comma null, then DBMS will not allow this kind of data and it will throw an error. It won't allow. Okay, that is what you want, right? So for that you create age as not null. So that is one thing, one integrity constraint. Apart from that, so not null is done. So we use not null on the field if you don't want to allow the null values. Second one, unique. Sometimes you can create a column with unique constraint. Okay, the purpose of unique constraint is so to not allow duplicates. Example, you don't want to have two different students with same name. Example, there is one more student, so her name is also Vani. Okay, so 25 is the age, you don't want to allow it. So it's domain thing, correct? I don't know why you have that reason, don't worry about it. Somehow you have that reason, okay? Somehow you don't want to allow the student names to be duplicates. If that is your condition, then what you can do is you can create S name as unique. So we can specify a condition that S name is unique. That's it. So while creating the table, you can do it. Now we will see what is primary key. Remember one thing, whenever you write unique, duplicates are not allowed. Sir, my question then, null values are allowed? Yes. Example, when S name is, student name is unique, then we can have one more null value, not a problem. So null values are allowed, not an issue. Understand? So, but only thing is, when value is not null, then such two values should not be equal. That's it. Sir, can I have another null? Yes. According to SQL standard, you can have any number of null values, because this null is unknown value, this null also unknown value. I am not sure whether they are equal or not. Correct? Don't match like this n, n, u, u, l, 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 and don't say that this null value equal to this null value, so unique constraint is violated. No, it's not like that, because two unknown values might be same, might not be same. I don't know. That's why better I don't discuss. I don't put any condition on this. That means people write to multiple null values, then I don't say that they are same. Okay, so why this kind of rule is imposed, I will tell you. Why two null values should be allowed. Example, if you don't allow, then you are saying that these two nulls are same. Do you know that? No. Then example, there is a person, he is writing his name null, another person is also writing his name null. There is a high chance that that names are different, correct? But there is very rare chance where these two are equal. That's why, so stopping them is not a good idea. So allowing multiple null values is usually the good idea. That is what people thought and realized. So that's why, so they put a condition that null values can be allowed, any number of null values when it is unique. Really you don't want to allow the null values, you put another condition on S name, that is S name is not null. Yes, we can have multiple conditions. So while creating the table, create table student, where student name is string, correct, student name string. So varchar you can write like this, create table. Usually I don't teach syntax because it unnecessarily takes our time. So create table student. So I only focus on student name, student name. So what we can do is varchar variable character of length 20 or something we can keep. After that we can mention that it is not null, okay, and unique in that way. So if you write like this, then uniqueness and not nullness will be mentioned, maintained. So now we will see primary key. What is primary key? So primary key is nothing but it's an attribute or set of attributes or column names where they will have two features. One is uniqueness, second one not null. That means any column you want to have without null values and without duplicates, go for a primary key condition. Okay, so generally primary key is whenever you impose an attribute that cannot take duplicate values, that cannot take null values. So example here, in my student table, the student id should be unique identifier, it should not have. So I will tell you the purpose of primary key, why I will make sid as primary key. I will tell you here, duplicate should not be allowed, that's why I can go for unique constraint. But second thing, so this student id should not take null values, then I can write not null, that's not a big deal. But rather than that, I can write primary key. Whenever I write primary key, then what happens? So your dbms will not allow null values, your dbms will not allow duplicate values. Sir, why to write primary keys separately? Why don't you write unique and not null? I will tell you. So whenever you create one primary key on the table, then it will help you in indexing. We will see there is a concept of primary index. At that time we use this primary key field. Okay, so apart from that, primary key is nothing but ensuring uniqueness and not nullness, that's it. Okay, now we will see the last important key constraint, that is foreign key, also known as integrity constraint. Especially this foreign key is known as referential integrity constraint. Okay, so referential integrity constraint, what does it mean and when we use it, we will see. How to understand foreign key constraint? For that I give two tables, student and enrollment. Okay, so student field contains student id, student name, and enrollment is about enrolling the, every student is enrolling the courses. That means example, some student want to enroll for a course C, then C++, then there will be entries like student id 1C 1C++, in that way. So this is the requirement I have now. Then what I do is, initially I don't keep any foreign key constraint. You don't know, let's say, what is foreign key constraint, then we try to understand the problems related to that. First of all, when you create a student table, you create like this. This is a syntax: create table, obvious, student table name, sid is a field which is integer and which is primary key. I want to make it primary key because so student id should be unique and not null, that's why I am creating as a primary key. And it has another purpose: whenever you create one field as primary key, that will help your table in accessing the data effectively, especially because of indexing techniques. So we will understand why primary key is required in indexing techniques. At this moment, let's say every table, it's better to have a primary key. Okay, so here, that's why I created sid as primary key, then sname as string varchar of 20. So this is the syntax of creating the table. Similarly, I created enrollment table. See, create table enrollment, id is integer, cid integer. Here I did not create any primary key. I will tell you the reason, because so there is a problem with foreign key. If you create a primary key with a id or cid, I will tell you the reason. At this moment, let's say no primary key, nothing for this table. So sir, why don't you create id as, first of all we'll see, can we create id as primary key in this enrollment? If you create id as primary key, then you don't want to write 1 comma 1, one id two times, correct? That is not allowed. Example, one student want to enroll two courses, 1C, 1C++. Then if you create id as primary key, then you can't write this kind of data, but you want such kind of data, then don't create primary key. That's why I did not create actually. So I did not create primary key and ID. I did not create primary key and CID. There is no purpose because you want to create, you want to repeat the course C so many times for so many students. Example, sometimes you have this kind of data, 1C, 2C, 3C. Then if I make student course ID as primary key, then you cannot have this kind of data, but I want it, then don't create. So finally, you don't require primary key and SID and primary key and CID. First of all, for time being, ignore about primary key concept for this table. Okay. Now here, let's follow these conditions. Only I created primary key and SID field of student, but here no primary key, nothing. Okay. Now, what are the problems you face? We will see. So student ID 1 and let's say student name Raju. It is a legal data, correct? It will be allowed. If you insert data like this, then it will be allowed. All the constraints, whatever you kept, only one constraint you kept, what is it? Integer and SID is primary key, right? So that you are maintaining. Now can you write 2 comma Rani? There will not be any problem here, right? Now what if I write 1 comma Rakesh again? Since you are repeating the data like SID, so your DBMS will throw an error. It says that primary key constraint is violated, right? So when you have primary key on SID, you can't repeat the data, and that is really important for me. That's why I did it, correct? So no one should write same student ID 2 times because every student should be uniquely recognized. That's the reason I created SID as primary key. So perfect. So far, conditions are good and they are helping me to maintain the legal instances of my data. Now see this situation. What if some entry, if I make like this, where ID is 3 and course is C. Some student is taking course C. With respect to only enrollment table, if you see, you simply said ID should be integer. Yes, ID integer. CID is integer. So let's take integer. Course ID is 001, which is C course, let's say. Yeah, perfectly. I am ensuring the conditions. You said ID integer, yes. Course ID integer, yes. So what's the mistake I am doing here? There is no mistake, but still for me it is a problem. What is the problem? There is no student called 3. How do you know that? I am consulting student table. If I look into student table, you will realize that there is no student called 3, but you are entering. So now this is illegal, right? It's not a legal data for me. But DBMS cannot understand it because DBMS can understand only one thing. The student ID should not have duplicates, that's it. It is maintaining that. But it cannot check that no, there is an instance 3 here or not, because so far with your conditions. So that's the reason. Finally, you want to say that, my dear DBMS, please try to maintain a link between these 2 tables. But how to explain that to DBMS? First of all, explain yourself. What is your requirement? Our requirement is no student ID should be permitted here unless it is mentioned here. If it is not mentioned here, don't write here. That is essential, correct? So from now onwards, such kind of conditions so far we did not learn. That is what foreign key. So what is foreign key condition is? So here, so the requirement is generally ID is not independent. It is dependent on SID. Without SID value, that means if SID doesn't contain a value 3, ID cannot contain. That is one thing. Second one. So from now onwards, insertions in enrollment are not so easy, correct? Remember it. What is not easy? Insertion in enrollment, correct? Let's say this is table number 2. This is table number 1. What is the significance of T1 and T2? T1 is a table on which there is a column which is referred by another table. T2 is a table which is having a column which is referring another table. So here I can say that T2 refers T1, right? Whenever you have linkage like this, then that is actually foreign key condition. Using foreign key condition, we can resolve it. We'll see slowly, okay? Before that, so insertion in enrollment is not so easy. We should do it in a careful way. Second one, let's say only valid entries if I write 1,001. Is it fine? Yes, it's fine. Now, suddenly if I insert one more person, 3,1, will it be a problem? No. So don't say that, sir, 3 is not here, so how can you enter? See, this ID is referring SID, but not SID is referring ID. So SID is an independent entity, so you can write anything. Only thing, primary key condition should be ensured. So 3 comma 1 is the legal instance, right? Now what I want to say is, after some time someone entered a data like 3002 3003. Fine. Is there any problem? No, because 1 is a valid student, you can enter. 3 is a valid student, you can enter, let's say. So far, how to ensure that condition we'll see later. We are just seeing our requirement, what we want. We want is, whenever you write the data in enrollment, the data's ID field should match with one of the SID values. That's it. Now see this scenario. So far these are all legal instances. Now if I delete one is suddenly, because when you maintain the tables, so many requirements come. Sometimes you want to delete the data, you want to insert the data. What if I want to delete the data? Is it okay simply deleting it here? No. If you delete 3 comma 1, again these two will become illegal. So again there is a linkage. That's why there is a link between two tables. So here deletion in T1 also. So deletion in table number 1, of course it is student, right? So deletion in student is not easy. We should do in a systematic way. Insertion in enrollment also should be done in a systematic way. These two. Anything else? Sir, what about insertion here? Yeah, you can insert anything. Everything is legal. So inserting here will not depend on this one. And don't say this, sir, can I write? You said anything, right? Can I write null comma null? No, it is not allowed because you are violating primary key constraint here. Apart from that, if you satisfy that condition, anything you can write. Sir, can I write 5 comma Rakesh? Absolutely not a problem. Second one, you can delete anything because see, when you delete the data, you are not violating any condition. When you add new data, that should refer this data, correct? So that's why I want to say that deletions in this enrollment. Suddenly, some student want to leave the course, so not a problem, correct? So that's why what is easy? Deletion in enrollment. So no need of checking anything, right? Your DBMS should not worry about this one, not a problem. One more thing is insertion in table number 1. Anything you can insert. That's why I can say that insertion in student, not a problem. So these are the things you should remember. Finally, these two things I should address. How to insert in enrollment carefully. How to how to delete data from this carefully. What are the strategies DBMS should learn and how DBMS should remember that these two are linked tables and how they are linked, correct? You tell me as a human being how they are linked. This ID field is referring this SID. So this ID field should not have different values than this SID. So I can say that forget about null values, I am going to write null values. Apart from null values, remember, I am not considering null values. Then this ID field should have whatever the values, okay? So that ID value should be subset are equal to SID is the condition finally. So this you should remember. Whatever this ID contains, that should be subset are equal to SID. So we'll understand foreign key constraint with various tables, like always do you have same condition? That means example in these two tables. So here enrollment ID refers SID, right, at that time. So what is your perception? What do you want? Example, if I insert data here, is it okay for you? Yes, okay. But can I insert here anything? No, not okay, right? So you remember, so we should tell DBMS that, my dear DBMS, from now onwards, there is a foreign key condition between them. I am going to specify that. So when I specify foreign key condition, don't allow me to insert any arbitrary data here. You stop me whenever I insert this kind of data, 3 comma something, 004. Don't allow me because 3 is not at all a student, correct? So that is one thing. Second thing, if I delete some data here, example 1 comma a, then what is the precaution? Otherwise, what is the step your DBMS should take to ensure the legality of the data? That means example 1 comma a is deleted. What are you expecting in the real world? In the real world, when 1 comma a is deleted, I want to delete all these instances because there is no such student 1. Then how that 1 can take courses here? This is student information, this is course information. Then there is no student 1. If 1 is deleted, then all the records of 1 should be deleted from enrollment, because when student does not exist, then enrollment should not exist, correct? So in that way, so what I can understand from this data is when 1 comma is deleted, all the corresponding tuple should be deleted. But don't think that always this is the only strategy. Sometimes in some other problems you might have a different requirement. I will tell you that. Consider these two tables here: employee, employee ID, employee name; project, here ID is employee ID, PID is nothing but project ID. So for every project, let's say there is one manager, I can say, otherwise one lead who is going to take care of the project. Okay, so now every project is led by only one person. If that is the case, what are the restrictions we have to keep? We'll see. This project ID should not be repeated. That is what I want to say. Why, sir? Try to repeat. Example, let's say 001 is the project and it has, let's say, another lead like 7. One problem here, one problem is 7 is not employee, correct? So let's take 2 here. So that is the thing. So is it allowed? 2 comma 001. Generally it should not be allowed, because what is my data's meaning is here 001 is a project ID which is led by 2 people. That should not be allowed, because every project should be led by one person. That is what my requirement. For that, you know what to do, think about it. Don't say that, sir, there are some companies where the same project is led by multiple people. That is not my case here. In my case, one project is led by only one person. If that is the case, so 001 should not be repeated one more time. So for that, what I can do is I can make project ID unique, so that no one repeats the project IDs, so that every project will be entered only once. So pretty cool. Second one, what if someone writes 7 comma 004? That means there is a employee 7 who is handling project ID 4. Absolutely wrong, because there is no employee 7, correct? So such kind of data should not be allowed. So what I realized, whenever there is a foreign key condition, see here there is a foreign key condition. So this ID is actually referring this employee ID, correct? Now you can't have data 7. What is my realization is, in these two tables, in this one and this one, in both of them, what can I understand is insertion in second table should not be allowed, correct? That is one thing. Second thing, when I delete here, example, in this table, if I delete data like 3 comma C, one employee is leaving the company. So what to do then? Example 1 comma A, if I delete from the employees, so this employee ID 1 should not deal this project, correct? Because he is leaving the company. So whenever I delete this data 1 comma A, then what about this project dealings like 1001, 1 comma 003? Think about it. So this is not same as this one. So some students say that, sir, follow the same strategy which you followed for student enrollment. When I deleted a student, what I did, I deleted all the corresponding enrollments. That was the meaningful thing over there. But here, this is not so meaningful here. Example, when you remove an employee, why should I delete my project? Because whether an employee exists or not doesn't matter, but project should go on, right? So project should be continued by someone. So if you delete this project, then that is meaningless. So here, the best strategy is, whenever a person leaves a company, then here my strategy is, we should write here some, at this moment no employees dealing it, so null. That is strategy number 2. So now what are the strategies we have to follow? We'll list out. Strategy number 1 was, especially it's all about deleting from the table number 1. When you delete from the table number 1, in the previous case, like in student enrollment, you realize that delete all the corresponding columns. Let's write it. Okay, so the strategy number 1 is delete all corresponding columns in table number 2, correct? So from now onwards, always I say that the table which is referred is table number 1. T2 means a table which is referring. Here T2 is referring T1, correct? So that's why I say that this is T1, this is T2. Here, so foreign key is here, right? ID is a foreign key. That's why this table is T2. Here this is table number 1, which is referred by someone, right? So in this model, so delete, strategy number 1 we can apply is delete all the corresponding columns in T2. But that strategy won't work for this combination. Then for this one, what should be the strategy? You just realize that we should write null value here, correct? So what you do is, don't delete, so replace corresponding whenever the deletion happens here. So replace corresponding columns. Corresponding column means this one id. Replace corresponding column value with null values, correct? So that is strategy number 2. What about other strategies? Only these two strategies are enough for you? Will it work for every data? No. Example, let's say this company has a requirement that every project should be handled by someone. So we can't say that some project is handled by null. Sometimes it won't happen. Example, let's say you are going in some flight. Suddenly one flight, the pilot who is riding that flight, so took off. That means he want to take some gap. So when he takes gap, if he comes out of that steering, then someone has to take care of that steering, correct? So immediately we should not say that for 5 minutes of time, so there is no pilot, null is driving, no, right? So that's why there should be an alternative. Here also same thing. If really these projects are important, some project, this 001 project was handling by this employee number 1. Suddenly if we leave the company, that means you are deleting the data from T1, then we should do one thing. One is we should take someone as default. That means this table should have, this project table should have some default person. Let's assume that there is a person called 7. Okay, so this 7 is the default person. I will tell you how to declare a default value. Let's say 7 is the default for project. From now onwards, whenever some employee leave the company, then that one is referred by this one right here. Then here what I do is I write here default value 7, default value 7. In the previous case also, you should write null and null. So that was strategy number 2. Strategy number 3, I can say that in the corresponding entries everywhere in the project table, you write default values. Let's say default value here is 7. So don't worry, while creating the table project, we can create a default value also, not a problem. Okay, so strategy number 3, right? So what is strategy number 3? I can say that here I show strategy number 3 is replace all the corresponding entries, correct? Replace all the corresponding column values with default value, right? So that is the strategy number 3. So there is another strategy. Sometimes I will tell you, let's say there is no default person. That means that default person doesn't know how to handle the project. Sometimes it happens, correct? So no one can be replaced. So this position is irreplaceable, sorry. So then what to do? So no one was ready to handle this project. We cannot write null. No one is ready to, even default person is not ready to handle this one. And third one, we can't delete the project. The fourth strategy in this one is easy to understand. Don't allow that deletion, because if you delete it, someone has to be replaced, but there is no such person at this moment. Then in this situation, what you do? Think about it. Only thing is, so don't allow that employee to leave. For that, what you do is give bonus to them, give a salary hike, everything, whatever he want, give car, everything. Then somehow forcefully we stop him. So yes, DBMS can do that. So sometimes we want it, right? So that is strategy number 4. What is that strategy number 4 is? Don't allow the deletion in T1. Okay, don't allow deletion in T1, right? So this is the strategy number 4. Let's summarize the strategies. Strategy number 1. Example, you are deleting a tuple from table number 1. Okay, we know what is table number 1, table number 2. You are deleting a data from table number 1, and that corresponding employee ID which you are talking about, which is already in the referred table T2. That means this one is referred by some people. In this case, what to do? Strategy number 1. What is that? Delete all the corresponding tuples. Sometimes it works, especially for student enrollment. That model, strategy number 1 works. For employees and project, that won't work, of course. Then we go for strategy number 2, which is nothing but in all the corresponding ID places, we write null values. That is strategy number 2. In the strategy number 3, what we do is we write default value, but before that, creating table itself, we fix a default value. Okay, so that is the third strategy. What is the fourth strategy? Don't allow the such deletion. Sir, my question is something else. What is that? Sir, I have data 4 comma D, sir. Is it allowed? Yes, In this table you can have any data. Suddenly I want to delete 4 comma D. Yeah, delete it. So then what to do, sir? What is the strategy I should apply here? No strategy is required here. The reason, no one is referring value 4, correct? So there will not be any problem. And one more thing, some students have this question, that is, sir, I am deleting 2 comma B. Yeah, then depends on the strategy. When you delete 2 comma B, assume that, let's say you are applying this replace with null. That means strategy number 2. Let's say if you are replacing that corresponding value 2 with null, then what happens? This will become null comma 002, correct? But when you, sir, when you started explaining as foreign key, you said that one condition, that is id should be subset or equal to employee id, you said, correct? That means column values in id should be subset or equal to employee id. Yes, I told that. But here null is not part of your employee id column, right? Then how this 1 comma null comma 1 is subset or equal to 1 to 3? Yes, it is not subset. That's why that is the exception, because if you want to really implement that strategy, so we have to write null values. That's why I told you at that time, other than null values, remaining values, that means that non-null values should be subset or equal to, otherwise they should belongs to this set employee id. Understand? So null values are exception. Remember it. So finally, you realized 4 things: how to insert here, how to delete here, how to insert here, how to delete here. Let's summarize. When you have a foreign key condition between two tables, I say that one is table number 1, another one is table number 2. Table number 1 is a table which is going to be referred. Table number 2, which is nothing but which is going to be referring. We say that T2 is referring T1. Okay, in that circumstances, so in table number 1 always we can insert. In table number 2 always we can delete. But in table number 1, while deleting, one of the strategy out of 4 should be implemented. But here some students ask one more question. What is that? Sir, which strategy? How your DBMS knows that strategy number 1 should be used, or 2 or 3 or 4? How it decides? Definitely it cannot decide. After all, it's a software. Software cannot work unless you write a program into it, correct? So that's why all these 4 strategies we have to embed here. So how to embed, I will tell you. So there is a command for it. For every strategy there is a different command. I will tell you that. Now what we do is, we take these 2 tables and we create them. Then later we write foreign key condition. I will tell you how to implement foreign key. That means how to specify it. Then how to specify default value, and how to apply the strategies. What is the syntax for applying the strategies, we will see. Now we'll see how to implement this foreign key. So let's say these 2 are the tables as we discussed, employee and project. So here employee id, employee name, id and project id. This id is going to refer this employee id. So one necessary thing you should remember, whenever you create foreign key, here id is going to be foreign key, right? So this id is going to refer this employee id, we know that. Then we say that this id cannot be independent. That means it is depending on employee id. Then this employee id field which is referred by this id should be primary key field. The reason I will tell you. The property of primary key is nothing but it will not have null values, correct, and duplicates are not allowed. What if employee id has duplicates like this? Okay, so since this id field is referring, example, there is one id field. Okay, so just I show picture really like this. Now there is a person who is referring this employee id. When there are multiple ones, if this is 1, so here this id is 1, then whom he is referring? This one or this one? Both are different, right? So that's why you remember one thing, whenever a foreign key is referring some other field, that other field should be primary key field. Then only we can uniquely refer it, correct? So I will give an analogy. Example, let's say there is a gated community. Okay, it's a very big gated community. In that there are some people are living, right? Now there is one person who want to come inside. For that he should come inside the gated community, right? So there will be a watchman. He will stop usually, right? Then this watchman asks a question. So my dear X, let's say this is X. Mr. X, who are you? I am guest. Okay, fine. So you are allowed inside, but one thing, where you want to go on to, I mean, which person you want to meet? That is one typical question this watchman asks, correct? So now I can see a relation between this and foreign key. That means this person is going to refer because he want to come inside. To come inside, he should refer someone in this community, right? Now, so this X will say that I want to visit Raju. Then that watchman asks, which Raju? That means what? You should refer a person whenever you really want to go inside. You should refer the person uniquely. If you say Raju, watchman will have again dilemma. What is that? Which Raju? Sir, what's the problem for watchman? Why watchman should ask which Raju? Why it is important for watchman? I will tell you. Example: this fellow is thief. He says that I will go to Raju's house, but he will not go. Let's say if he enters with that reason, then what he can do is, if he does some mischievous thing, if he steals something, then after that, so then people ask watchman, who came? Some X. To which house he came? Raju's house. Which Raju? There are multiple Rajus. Then we can't claim that, so whom he was referring, right? It will be very difficult to trace, like the thief. That's why whoever comes, doesn't matter for watchman, then that person should uniquely tell the address, correct? That's why watchman asks this question. Mr. X, you are referring someone, but you have to refer him uniquely. That means the example you are saying name, right? The person's name, you just said Raju, but there are multiple Rajus, so I don't listen to that kind of things. You give unique identifier. So you just, then this X will say, my dear watchman, then how to solve this problem? So I know only that person name as Raju, I don't know anything else. Then this watchman says, do you know the house number? Yeah, I know the house number, it is 288. Fine. So this house number is uniquely, referring one particular house. So now this fellow, once he goes, if he does some mischievous things, then we can catch that house number 288 people, correct? For that, from now onwards, you remember, this person X should give answer such a way that, otherwise he should refer a person inside the gated community in a way that should be unique. For that, he should give house number, otherwise person number with some passport number, otherwise some Aadhaar card number, otherwise some unique identification number he should submit here, correct? So similarly here also, whenever this ID is referring this employee ID, this is like a person X, he is referring employee IDs, then that employee IDs should be unique, correct? Only such fields we have to choose, right? So from now onwards, blindly remember this project ID, that means, sorry, this employee IDs in this project should refer this employee IDs uniquely. For that, this employee ID field should be unique. Some students argue that, sir, this employee ID, this field also should be primary key. No, not required. Why? Try to, sometimes, some person want to access multiple, want to lead multiple projects like this. We should allow it. So there is no purpose to have primary key here. So that field, so employee ID field should be primary key, but not this one. Okay. So finally you realize that this ID is going to refer this employee ID. Such field should be a primary key field, remember. So that is a necessary condition according to SQL standard. Now we have seen the reasoning also, correct? So really you are referring someone, you should refer it in a unambiguous way. For that, you should refer only primary key field. That's it, quite obvious. Now we will see how to create such tables. So, and how to mention the foreign key condition. See, create table, and one more thing, you don't want to repeat the projects, right? That means one project should be handled by only one person, then project ID should be unique. That's why I created project ID with unique constraint. Let's see. Create table employee. So what is one condition? Employee ID, because this employee ID is going to be referred by someone. That's why that employee ID, which is integer, primary key, right? Then next field is employee name. There is no condition on employee name. So employee name is varchar20. Sir, every employee should have name, sir. Then you write not null, not a problem. So that remaining things which are not so important and they vary depends on the data. So I'm not worrying about that. Now say take the second table. In this create table project, first ID. So what is the data type of ID? The domain type, integer, right? Next, project ID is another field which is varchar of 10. That means I want to represent it as a string. Followed by, so this project IDs should not be repeated. That's why I made it unique. Understand? So next, foreign key. So of course you can make this project ID primary key also. But if you make project ID primary key, not a problem, so that no one will write null values also. So either you write unique, otherwise primary key if you want. Now see, up to now I did not mention that this table is linked to this table, right, so far. But now this is the time to say that, my dear DBMS, see the syntax. I am going to say that this project table is related to employee table. For that you write foreign key. You know that there is a foreign key relation. So foreign key on which field you are creating? ID field. That's why you write like this, foreign key on ID field. So and it references what? We should write here, references which table? Another table. What is the table name? EMP. Now if you write this one, foreign key ID references employee table, then automatically, so your DBMS understand that this, because you are writing foreign key in this table means what? Project table, right? In project table refers employee table. Some students ask this question here, sir, you did not mention on which column. That means ID is referring employee table, but which column? We know that it is employee ID. Don't we write here employee and especially on employee ID? Yeah, you can write employee of EID, but it is not compulsory. Why, sir? I will tell you. We know that if and all if this ID refers some other field, like if ID is a foreign key, it should refer another field, right? That another field should be primary key, already I told you. Now if that is the case, in a table there can be at most one primary key. So your DBMS is smart, it can understand that. So my dear user, I understand that this ID is a foreign key and it is referring employee table. Especially in employee table there is only one primary key field. That means you are going to refer directly employee table's primary key. Without mentioning that also your DBMS can understand. That's why specifying that is not compulsory, right? So far we mentioned the foreign key condition, but strategies. So we want to apply the strategies, right? Example, what strategy you want to apply? I want to apply strategy number 1. What is that? From now onwards, when there is a foreign key condition, every project is important and there is no default person, because I did not mention any default person. If someone leaves from the company, example, Raju is an employee and he is handling a project called 001. If Raju leaves from the company, I should not allow it. If anyone is handling the project, they should not leave the company in between. If that is the case, then we can write after this one, write like this, on delete. So all that strategies are about deleting from this, right? That's why we write on delete. So no action. So that is the one thing. So if I say on delete no action, then what happens? Your DBMS will not take any action. That means it won't delete. So if you write a query delete from table employee where employee ID equal to 1, simply your DBMS says that, my dear user, you don't have permission to delete this value because in table number 2, so there is a on delete no action. Understand? Second strategy, if you want to implement this strategy, what is that? Whenever an employee want to leave, projects are not so important for me, then automatically I would like to delete him from all the projects. That means you want to delete 1001, 1002, all. So that means you want to have second strategy. Then what is that? On delete cascade. Okay, whatever the strategy number, don't remember it. So I might change the order. Here the second strategy, I'm explaining the strategy, right? Delete this row and delete all the corresponding tuples. So that is on delete cascade. Whenever you write on delete cascade, this tuple will be deleted whenever you want to delete. It's not automatically deleted. If you delete this tuple, then all the corresponding tuples in this foreign key table will be deleted. That is on delete cascade. Now you want to implement another strategy called, replacing with null values. That means whenever project is handled by a person leaves, then you replace all that entries with null, right? If you want to implement that, then you write on delete set null. Similarly, we have on delete set default, last strategy. Okay, so that is on delete set default. But when you write on delete set default, it gives you error. Why? You did not mention what is default, correct? So what is default here? So it's domain and subjective, I can say. That means it depends on the subject. That means, so who is maintaining these tables and what is the meaning of default for them? Example, this is your company and you are going to decide who is default for projects. Let's say there is an employee called 7 who is permanent employee, he can't leave the company, let's say some reasoning is there, then that fellow is going to be handling all the projects if someone leaves the company. Then you do one thing while creating the project table. So here id is integer and you write immediately after this one default. So what is default value for that id field? Default is 7. If you write default 7, then from now onwards 7 will be so default. That means he is a imaginary employee, that's it. So this 7 is especially used by your DBMS to execute this or specify this condition on delete set default. Example, you mentioned default is 7. What happens? We'll see with some data. Example, there is an employee called Raju. Raju was handling this data like this 1001 1, let's say 002. He is handling two projects. There is another girl called Rani, 2 comma Rani, but she is not handling any project. Now suddenly you wrote a command like this, delete data like this. So this is a command for deleting. Delete from table. So delete from, what is the table name? Employee. Values. Delete from employee values. What are the values you want to delete? 1 comma Raju. So when you write this command like this, what happens is, so 1 comma Raju will be deleted. Before that, your DBMS knows that these two tables are linked. It will first of all come to project table and it will see all the entries with corresponding to 1. Yes, there are two corresponding entries for this one employee. Then automatically, because of foreign key condition, it will see the strategy. We wrote the strategy called, let's say, on delete set default. If you write that, then automatically this 1 will be replaced with 7, this 1 will be replaced with 7. That's it. But don't say that, sir, in this employee table there is no employee 7. It's up to you. It's not compulsory. So your DBMS simply uses that 7 value for replacing it. It doesn't matter really there is employee 7 or not in your company employee. Understand? So this is about on delete set default. Remember it. Okay. Now we'll see one more thing. So far we have seen how to do insertions in when there is a foreign key condition, right? And how to do deletions we have seen. But how to do updations? Sometimes we do updations in the table, correct? So how updations works in the presence of foreign key? So here I am using, this is employee table and this is project table, and especially this employee ID which is going to be referred by this employee ID, right? So there is a foreign key condition like this. Now in this scenario what happens we will see. So update. Example, if you update this value in employee table. So can I update 3 to 4? If you make 3 to 4, anybody is referring 3? No one is referring. There are only 2 employees are handling the projects, correct? So employee 3 is not referred by anyone. If you write 4, there is no problem. Then see this one. What if you update here this to something called 7 or something? If you write 7 here, then what happens? So many people are referring, see here, 1 is referring this one and this one also referring this one. So what to do? It's like deletion. Same strategies we can apply. So on update also we can do 4 strategies. So for that we have to mention like this. On update, no action. Second one, strategy number 1. Strategy number 2, let's say on update, cascade. Third strategy what we can apply is set on update, set null, and on update, set default. So these are the strategies. Let's see one by one. So if really no action is implemented, if you write on delete, on update no action, what happens is if you make 1 to 7, that will not be allowed. So your DBMS says that, my dear user, you can't do it. Why? Because the condition we mentioned is on update no action. That means, so this one is referred by so many people, so they don't allow you to update it. Fine. So that is the meaning of on update no action. So when there is no on update no action, such updation is not allowed. It will throw an error. So it will be remaining like this only. Next, if I use on update cascade, if I do on update cascade, what happens is, example, if you delete 1 comma a, then what we have to do is all the corresponding entries, one is referred here, right? So these two ones are referring this one, then they will be replaced by, so because you said on update, right? So on update, So if you make it, so you are updating 1 comma a to something, let's say 5 comma a. Okay, so you are just updating this value 5, then this will become 5, this will become 5. So easy. Now third strategy, on update set null. Example, if you update this to something like 5 here again, 5a in the place of 1, if you write 5, then if you use on update set null, what happens is this 1 to 1 was there, right? So this 1 will become null because the you are referring 1 is replaced by 5, then these ones will become null. That is the meaning of on update set null. If someone updates your value which you are referring, then you will be modified to null. The last one is on update set default. So example, that employee number 1 is changed to 5, then so many employees, one, see, two projects IDs are, I mean, in two entries in the projects are referring this one, right? Then they will be changed to default. What is default value? Already this project table will have default value, that was 7, right? So this will be replaced to 7 in that way. So in the same way like on delete, we can implement on update and all these things. Let's summarize. So if you change, example, you are updating a value which is referred by project table, then in on update no action, that is not allowed. Second one, on update cascade. In on update cascade, so your updation will be allowed, but all the corresponding entries also will be updated with the same value. Example, if you change 1 to 5, there also all the ones will be changed to 5. Next, on update set null. So in that one, when you update, example, if you update 2 to something 9, then 2 is referred by someone here, right? So that will be set to null. Then on update set default, instead of null it will be set to default value which is 7. So this is a concept of on update and strategies. Okay, so we have seen finally how to insert the data, how to delete the data, how to update the data in the presence of referential integrity constraint. If we have, right, foreign key, self-referential integrity constraint. So of course that is also a foreign key, but when you get this self-referential integrity constraint, we will see. Example, you have collection of employees and their managers all in one table. So I am showing only two columns, but imagine that you have other columns also like employee name, salary, everything. So to simplify the things, I am using only two things. Okay, so you imagine this table as all the collection of employees, all the information followed by the corresponding manager of that employee. Example, if I write initially, if there is only one employee, then I write like this, employee ID 1, let's say his manager is himself 1. Then if I, let's, after that I insert data like this, 2 is one more employee, his manager is 1. So 3 is a next employee whose manager is 1, in that way. So 4 is an employee whose manager is something 2, in that way. So we can write any data. Now I am going to write some data, you tell me whether it is correct or not. There is an employee called 5, his manager is 7. Is it meaningful data? Just forget about the conditions. You just see the data and tell me. So there is a mistake in this entry. That is, 5 is an employee, okay, and you are saying that manager is 7, but really he is a manager. He should be one of the employee, but 7 is not at all in the employee set. Correct? That means, so this is a wrong data. So it is wrong data because it's not because this is, violating the primary key conditions. Correct? Example, 7 is a valid data. 7 is a, because what is manager ID? It should be some integer, let's say. If really manager ID is defined as integer, any integer I can write. But why you want to say that is wrong? Why it is wrong? Because this 7 is not part of this employee ID set. Is it not a foreign key condition? You want to say that manager ID always should refer employee ID. That is what your intention, for especially for this data. Correct? So this is the condition, finally foreign key. Now observe that foreign key. Where is foreign key? Manager ID is a foreign key. And it is referring what? Employee ID. So far we have seen foreign keys referring another tables, right? But here this foreign key manager ID is referring same table, right? That's why it is called self-referential integrity constraint. So a table refers itself using foreign key condition. So you should be very careful when you have such thing. How to create such table I will tell you. So one essential thing is, since manager ID is referring this employee ID, it should be primary key, correct? So let's do that. So your syntax will be like this: create table. What is the table name? Employee, let's say. Create table employee, and the column names are, one is employee ID, right? So what is the field type? Integer. Anything else? It should be primary key because this is going to be referred by someone. So primary key. Anything else? Manager ID. So manager ID is integer, let's say, and it is going to be foreign key, right? Then we should mention that. So manager ID is integer followed by, I am writing foreign key condition now. Foreign key of manager ID. So that means, manager ID is a foreign key. References what? Which table? Same table, right? That's why we should write references employee table. Correct? Then on which field? Not, it's not compulsory to mention because by default automatically employee table's primary key, which is employee ID. So your DBMS understands. After that we have to write strategy name. So sometimes if I don't write any strategy, is it syntactically error? No. When you don't mention any strategy, then automatically it is on delete no action. Okay, but let me write a strategy called on delete. Let's say cascade. What happens we will see. If you do this, question number 1, is it meaningful data? 5, 7 will not be allowed. Whenever you write 5, 7, so example, if you write 5, 7, then immediately DBMS says that, my dear user, you wrote 7 here, but 7 is manager ID, which is referring, employee field, employee tables employee ID, that means employee ID, but there is no 7. I am sorry, don't write 5, 7. So it will be restricted. Okay, now you have this kind of data. So can I write 5, 3? Simple. Whenever you write data, this field should be examined. 3. Yes, 3 is an employee. So it will be allowed. DBMS will allow it. Okay. Now in these circumstances, in GATE exam, what kind of question they ask is, so they ask like this: if some data is deleted in this problem, if some data is deleted, what are the number of tuples deleted? We will see there is it's a tricky thing here, you should be careful. Example, if I delete 1, 1, so what happens we will see. To understand that, so I am remembering these conditions, I am erasing this part. So what I do is, I take one more table and I say that there is a mirror. That means both are same tables. Here employee ID, manager ID. Let's copy the data because it's a mirror. 1, 1, 2, 1, 3, 1, 4, 2 and 5, 3. Only for imagination purpose I am taking two tables, but both are same. Example, if I delete data from one here, then this data also will be deleted because both are representing same table. Just I am showing for good visualization. Now we know one thing. What we do is this: if I imagine my one table as two tables, so this can be imagined as table number 2. This can be imagined as table number 1. You know what is table to table 1 concept, correct? So this manager ID is going to refer this employee ID. So of course this manager ID refers employee ID. So this manager ID both are same. If I represent two tables, it will be easy for me to see the foreign key condition, right? Example, if I delete 1, 1, is it not like deleting from table number 1? Yes. So whenever you delete from the table number 1, according to referential integrity constraint, what is your strategy? On delete cascade. Then we should see this 1, 1. Anybody is referring, I see, this is 1, right? So you are going to lose 1. When you lose 1, then immediately come to the table number 2. So is this 1 is referred by anyone? This manager ID field is referring, right? Yes. So this here it is referred, here it is referred, here it is referred. Then we should delete because it is on delete cascade. So delete all the corresponding entries. Delete it, however we are deleting it, and delete 1, 2. The reason is what? Your 1 which you are deleting is referred by this tuple and this tuple. That's why we have to delete it. That is what foreign key condition. Now, since it is mirror, so here also it will be deleted, right? Now you should be very careful because new tuples are deleted. When new tuples are deleted, again we have to check that foreign key condition. This 2 might be referred by someone, this 3 might be referred by someone. Let's check it. Okay. So remember 2 comma 3 are just deleted now. So 2, is this 2 referred by any foreign key? Yes, here 2 is referred. So this tuple also should be deleted. Then only we say it is undeleted cascade. So 4 2 is deleted here. Since it is mirror, here also it will be deleted. Both are same. Now you remember one thing. Now 2, 3, 4. 3 new elements are gone. So anybody is referred by 4? No. That means 4 is not a manager to anyone. 3 is manager to anyone? Yes. 3 is a manager of 5. So it's like, so try to understand using common sense. If you delete an employee 3, then if he is manager to some other employee, that entry should be deleted, correct? So that's why we delete this one. Now let me stop here and ask this question. Why I am deleting this one? Because you deleted data called 3 comma 1. When you deleted 3 comma 1, 3 was referred by this 3, correct? According to foreign key condition, if some foreign key refers some data, then when you delete that data, all the corresponding entries in this foreign key table should be deleted. That's why, since both are same tables, they will be deleted in the same table. So 3 comma 5 will be deleted. Then automatically this will be deleted. Why? Mirror. So in that way, so total data we lost, right? So that, so you might have this purpose for that, correct? So don't worry about the losing the data. That is not your intention. So finally, in the GATE exam, they give this kind of things. They say that there is a table and there is a self-referential integrity constraint, and on delete set cascade is on delete cascade is used. Then what happens? How many tuples will be deleted? In this problem, 1, 2, 3, 4, 5. Total 5 tuples will be deleted. We'll see one more example. So employee table, employee ID, manager ID. Same story, like manager ID is the foreign key which is referring employee ID. So on delete cascade is used. Now the question, if delete, so you know the syntax for deleting, right? Let's say delete 1 comma 2 is used. Example, if I delete 1 comma 2 from this table, what happens is a question. How many tuples overall will be deleted is a question. How to solve this kind of questions is, the best thing is take one more table and say it is mirror, and always maintain 2 copies. So again employee ID, manager ID. This table you use to refer, otherwise to see foreign key. This table you see to see the primary key. Okay. So here this manager ID is going to refer this employee ID. Remember it. So let's copy the data 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, 5 comma null, and 6 comma null. Let's begin. So delete 1 comma 2. So when you delete from table number 1, automatically here also it will be deleted first of all. Since it is on delete cascade, we are going to delete it. But only thing is, so this one is referred by some foreign key. Yes or no? Yes. So where it is referred? Yes. So not there is, nowhere it is referred, correct? So when you delete employee ID 1, then this one is not referred by anyone. So there is no problem, right? So though it is on delete cascade, nothing new will be deleted. Understand? Ask yourself. 1. This one is referred by manager ID? No. Stop it. So in this on delete cascade model, if I delete 1 comma 2, only one tuple will be deleted. But if I modify this query to, this table to 1 here, 5 comma 1, then what happens you see. So if I do delete 1 comma 2, then what happens initially 1 comma 2 will be deleted, right? So delete it. Now this one, is this referred by anyone? So here 5 comma 1, right? Yes. This is the entry which is referring 1. So you should be very careful. Don't see in this employee ID field. This employee ID field is referred by whom? Manager ID, correct? So manager ID is a foreign key. In this manager ID field you should see, is there any one? Yes. Then delete it. That is what on delete cascade. But if you delete 5 comma 1 here, you will lose here also. Now it is like in table number 1, you lost 5 comma 1. Whenever in table number 1 some data is deleted, we should see what is the referred value 5, right? 5 is referred by anyone in this foreign key field? Yes. Then 4 comma 5 will be deleted. If you delete 4 comma 5, this will be gone. Then what is the employee ID of this 4 5? 4. Is this 4 referred by anyone, any foreign key value? Yes, here. Then this will be deleted. If 3 4 is deleted, this will be deleted. That is what on delete cascade. So now 3 4 is deleted. Then is this 3 is referred by anyone? Yes, 2 comma 3. So why are you deleting this, sir? On delete cascade. So whenever you delete from table number 1, all the corresponding entries to be deleted from table number 2. So 2 comma 3 is deleted. So here it is also deleted. Some students ask, they will forget that both are the same tables. They say, sir, why are you deleting 2 comma 3 here? Both are same tables. So you have foreign key in the same table and main primary key in the same table. So that's why whenever 2 3 is deleted, so here also it will, sorry, whenever 2 3 is deleted here, that will be deleted here also, because both represent same table. So in that way 2 3 will be deleted. Anything else? No. So finally 1 comma 2 2 comma 3 3 4 4 5 5 5 5 1 all will be deleted if you use on delete cascade. But 6 comma null will not be deleted because 6 is not referred by anyone in this manager ID field. So this is about on delete cascade in and self referential integrity constraints.